Steel shell technology opens exciting cost-saving opportunities for offshore and coastal projects. For bridge piers, wind turbine foundations, harbors, oil piers, loading facilities, channel markers, offshore platforms, the idea is simple. Steel cylinders filled with crushed rock provide excellent stability. Under dynamic loads, a ring footing is needed to avoid slippage and increase stability. Stiffeners are natural continuations of the ring footing. They may be needed to deal with high local loads. The concept is easily demonstrated in small-scale tests. It is almost impossible to destabilize the wall because the filler material has such a high friction angle. In contrast, backfilling with loose silt presents challenges. Lighthouses and channel markers are an ideal area for application of steel shell technology. The light shell is easily placed in the water. With an air bubble inside, the shell can be towed to the site and sunk by releasing the trapped air. An overturning test confirms the geotechnical performance of the shell. As this is a new concept, we test and analyze the stability of the structural model to have confidence about the full-scale design. In 2010, the wind power company Eranti built a pilot turbine off Finland's west coast. The pilot was the first use of steel shell technology in a wind turbine foundation. Today, a 40-megawatt wind farm based on this technology surrounds the original pilot installation. Developing and testing the ice-resistant foundation started in the late 1990s. Many overturning tests and dynamic small-scale tests were performed. Local pressure tests confirmed that the rock-filled shell had a huge capacity reserve beyond its elastic range. Bridge piers have emerged as a novel area for application of steel shell foundations. As an example, we now have a straightforward answer to the long-dreamed Kvarken link connection between Finland and Sweden. Just place the steel shells on prepared bottom and fill with crushed aggregate. Now you have foundations that can easily take a moment of several hundred meganewton meters. Here we see a lateral stability test for an offshore platform with 2 shells. The trend in offshore and coastal engineering is towards simple solutions that dramatically lower costs. Easy to manufacture and install light steel shell structures are well suited to many purposes and conditions. For offshore oil and gas development, for coastal engineering applications, steel shell technology from Eranti Engineering and Elomatic.